to stand? Thank you very much. At this point, we'll move over to the Q&A. And I will move to my place in the audience. We will use the cameras which will zoom in directly to the speaker. But first of all, let me ask, are there any questions from the audience to the speakers? No? Okay, then I will move over. Okay, I think we'll come back to GPS a little bit later. But first of all, I have here a question from Bojan from Slovenia for Wolfgang Peters on TPEG. Bojan asks, I've seen that TPEG data is transmitted in DAB+. When talking with DAB receivers for cars, they don't integrate TPEG anymore. What is the current situation for TPEG in DAB+?
Yeah, that's absolutely true. What Bojan mentioned, the car receivers, I learned that also from the manufacturers that they stopped to implement the TPEG functionality. But it was at that time, as we started with Poland and NDR, TPEG was in the cars. I had also in my car, in my own car, and TPEG receiver inside and was combined with the navigation system. But at the end, I learned that it's no longer necessary because everybody is using probably Google Maps or Apple Maps or whatever. And that's the reason why manufacturers have decided not to go ahead with TPEG. And of course, my recommendation is use the capacity for other things. The same is true for EPG. If you look to receivers who can decode a full EPG, I cannot find or I cannot say which receiver can do that. And of course, the most users transmit only the station logos via the SPI. That's it. And that's also my recommendation. Do other things, increase the audio quality instead of wasting the bandwidth with services which are no longer really useful.
Yeah. Thank you, Wolfgang. I hope this answers the questions. There is just come in another question for you, so I'll keep you warm. In the Polish public warning system, can the crisis announcement be considered an emergency warning system, EWS? Is it compatible with the radio player? And is it based on an open standard or a proprietary solution? The question comes from Antonio Ferreira from Portugal, from RTP.
Okay. So the implementation we did is based on our tunnel break-in system. So what we do is with the additional encoder at the Polish authority is that if we press the red button to make an announcement, then we replace all subchannels in the multiplexers with the announcement signal. Yeah, so that is seamless. So the multiplexer is really exchanging all the audio signal of the subchannels. So that's the same what we use in the tunnel break-in systems, and that's the magic behind. Yeah, and I think it should be compatible with all receivers, also with the very old DAB receivers. Yeah, so we can do that also for all DAB receivers. There is no limitation. At the end, the receivers do not really recognize that there is a new signal inside. And we look into the signal, what is the lowest bit rate in the multiplex, and then we adjust automatically the bit rate of the announcement encoder. Yeah, so we have, but in Polish radio it was very simple because they use for all programs the same bit rate. So that was an easy thing, but the algorithm behind could also recognize if something happens with the bitrate management, if they change during a reconfiguration something, then we could automatically adjust the bitrate of the announcement encoder so that you're 100% sure that we have on the remote side, and that you can listen to the announcement. And for the other, of course, you can combine it with other. Yeah, so it depends what you want. Yeah, so if you want to reach, because if we are thinking about the introduction of ASA, that took time. Yeah, at the moment we have roughly 40 receiver manufacturers, and if all the people have now ASA capable receivers, I think we need 2, 3, 4 years. I don't know. And in the meantime, of course, it's a good possibility to do that via such a functionality. So we offer in our multiplexer both. Yeah, you can also combine it, and that's the solution for the time when we have all ASA capable receivers. Yeah.
Great, thank you very much, Wolfgang. I have another question. It's for you, but I want to open it up for the other speakers also from Antonio Ferreira, because I think this is an interesting discussion point for all of us. Given recent disasters like fires, floods, power outages, how resilient do you think are cloud-based and streaming-only solutions without satellite distribution? Because this architecture appears unsuitable for an emergency warning system. What do you think? Can you confirm this, or do you have a different opinion?
To be honest, I do not see really the cloud solution. Yeah, of course we have always to look. What do you mean with cloud? Yeah, if you go to a public broadcaster, they all have their own cloud typically. That is okay, but I would never install really. If a customer asks me, can we run that on an AWS cloud system or something like that? Of course you can, but I do not recommend that, because we know that Facebook fails, WhatsApp fails all the time, and there is no 100% security. And on the other side, you need typically for cloud solution, you need a longer buffer. Yeah, and then you have typically a higher delay. And for traffic announcement, for example, it's a nightmare if you have the driver on the wrong road, and you can warn these drivers via DAB 30 seconds too late. That can be a really too long time. Yeah, and therefore I would never really recommend a cloud solution.
LP?
Yeah, let me fill in with saying that in the latest incidents that we have seen, for example, the flooding in Germany, the first thing that happened was that the mobile networks were down. And second, all the internet connections were down. The only thing that was up and fully operational was radio, broadcast, FM and DAB. And that was the trigger in Germany for inventing a new standard, the ASI, for emergency. So it's proven that broadcast is the only system that works in most crises without mobile and internet.
One remark, I was also in Portugal as the blackout happens in Spain and Portugal. And it was really fast. We recognized exactly at 12 that we have no power. And at 12:30, we have nothing. We have no mobile reception. We have no internet. And of course, everybody was looking in the internet what happens, and we collapsed by ourselves, the complete internet. That's crazy. And the only chance to get information was go into the car, switch on the radio, and then we had a translator in Portugal, which translates all the broadcastings, and to hear what happens really, because in the beginning we thought it's a cyber attack from Russia or something. Yeah. And that it was 9 hours. We had 9 hours, no internet, no mobile, nothing, and that was really strange for us. Yeah. On the other side, it was an experience, definitely. Yeah.
Okay. I would like to ask also Stan on this, because Stan, with Tigris, you do everything basically IP-based. So you're really on the other side. You showed us how you manage the redundancy. Do you think you can build an IP-based distribution without the internet?
Yes, in fact, when we say we are 100% IP, doesn't mean that we are only internet, because IP is just the transport protocol finally. But that's why we install our own radio links between sites. That's why also we did invest and pay at the high price the fact to run our own fiber from a different place to another. When I say our own fiber, I mean it was no fiber there, and so we had to pay to make to run fiber over 2 kilometers. That's why we in fact secure where we have our office and the different place via radio links the network over the national distribution, because it's exactly that. The problem is more you put things on third-party service, let's say, and less you have control, and you don't know what are their priority. You can sign SLA, you can sign a lot of things, but SLA are when everything is good. Unfortunately, as soon as you have a real crisis situation, forget the SLA. The priority is to make things working, etc. And if you have to start with lawyer to say no, the SLA like that, you are in deep trouble. It's too late already. So you must, in fact, always think forward to say, how can I be independent? And I think it is really something which is from the roots of broadcast since years. It was always, okay, how can we be resilient here? How can we do that? Yes, internet is resilient in the sense that you have a lot of distributed infrastructure, but the problem is always it's not really the infrastructure, it's the priority of the different actors here, what they will do. And the business of the radio broadcast is really small compared to the huge international business of the big company on internet, meaning you will never be their priority if you have a problem on your service on their infrastructure.
Thank you very much, Stan. I agree on this last part very much. Okay, going on from, let's say, on the switching part, Arne and Tork, I have a question for you. You mentioned the backup switching at the transmitter side. What do you think can be done at the transmitter side when you are in the reception of the different feeds to have a very reliable technology?
Yeah. So in contrast to the redundancy switching, which you can do. So redundancy switching means you get the streams from the head end, A and B, redundant. You can basically do some seamless switching. And in addition to that, if those feeds completely fail, you can have our device having a fallback to an alternative source, so backup switching. This can be, for example, a separate disaster recovery site with an own multiplexer, or it could also be based on receiving the DAB signal from another region and using this as an alternate source, for example. So that's what backup switching means. You have not, of course, also to consider how to activate that. So it can be an automatic fallback. You can also manually activate that fallback. And we have also a management solution which can control the devices in the field, where you can centrally manage such functions and sending commands even over satellite feeds or satellite connections, so that you can manage the functions of the devices and also the backup switching.
Thank you very much, Arne. Interesting. Now it's time for Alex. I have a couple of questions for you also. And one comes from KB, who asks again about redundancy, asking, is it implemented at every stage of your DAB transmitters, or if there are specific costs to implement redundancy inside the transmitters?
Okay, the redundancy in power supply is typically from a certain power level up. So the minimum power level that supports a 3 power supplies is about the kilowatt. Every power amplifier and every transmitter with a higher power has those 3 power supplies. So that redundancy is in every transmitter that has a higher power. And at that level, you can start connecting the transmitter to 3 phases, again, giving you not redundancy, but less dependence on a single power source coming from the grid. The other part of the question I understand is the number of pallets that you have in a transmitter, again, is a function of how much power you want. If you're looking at, let's say, 80 watt or 250 watt, you have a single transmitter. Of course, there is no redundancy. But starting with medium power levels like 500 watt to kilowatt, you have multiple pallets that are combined inside the transmitter. So there's an internal combiner. And again, that gives you a certain level of redundancy. All units can operate either with a dual drive if you have multiple power amplifiers, or you can run them in a 1+1. So again, that would give you a certain level of redundancy. I hope that answers the question. Otherwise, you can always contact me directly.
I hope so too. You answered also a question from my side, actually, a little bit. Because I mean, being one of your customers, of course, we buy a lot of smaller transmitters because of the typology of the network. So you talked a lot about the options for medium and big size transmitters. Is there any advice you want to give, let's say, especially to operators coming to DAB? To make installations for small transmitters as resilient as possible?
The first thing I think I agree with Arne is try to have 2 paths of sending the signal to the transmitter. Use a microwave link and a backup on fiber, or fiber and backup microwave. If not 2 of them are available, put a mobile phone modem in there. I know the quality is bad and the bandwidth is not guaranteed, but it's an emergency scenario. The second one is, depending on your obligations towards the content providers, try to have either a redundant system like a 1+1, or in a medium level, and here I'm speaking of 300 watt upwards, you can have a power amplifier with 2 exciters that makes the station more reliable. Consider an uninterruptible power supply, UPS for the exciters, the network equipment, as Stan said earlier. I didn't mention it in my presentation earlier, but think about a fire suppression system, automated halon equipment, for example, to extinguish a fire if something burns. And why I'm saying this is that when I mentioned earlier in my presentation, transistors occasionally burn, and they literally burn very hot. So that might start a fire inside the station. Those are for the medium and smaller power.
Thank you.
Okay.
So, Carlo, I didn't forget you. So, do you think, or what's your idea, when planning DAB coverage, should I start immediately think about resilience of the network when I plan it, or do you think this is something which could be introduced further on? What's your opinion on this?
Well, I think that yes, you can think about the coverage resilience from the beginning. Of course, the network rollout is step-by-step activation, but it must be supported by a solid network planning antenna design. And in this way, if we are thinking about the benefit of the SFN network, especially for DAB, we can plan, for example, the overlap of the signal intentionally to limiting the problem. And otherwise, it's also possible identify which is the worst case in case of one tower, one transmitter, one antenna failure. You can identify from the beginning the worst scenario that's cause coverage losses. Otherwise, in my opinion, you have to identify from the beginning which is your target. So the target is a defined population or a preferred area, or, for example, you can identify the route of the highway. So if the target is clear, thanks to the SFN benefit, you can plan something from the beginning.
Okay. Thank you, Carlo. So, do you think this is a good one? Do you think it's more cost effective? And let's say I look at Carlo and at Alex, because you're in competition in this question. Do you think it's more cost effective to have, let's say, redundant transmitters or a little bit more denser network? And then, let's say, have a network resilience.
I know you answer.
For me, it's not an either or question, because having a resilient network, a denser network, gives money to us because you need more transmitters, right? Having more redundancy on the individual transmitter sites is also good for us because it gives more money to us. So for me, it's a win-win scenario. It comes down, from my perspective, it comes down to the question, what's the consequence if a site goes down or if you have a lower coverage? Are there penalties involved with the content providers? How long do I need to get to the site? So in example, what Stan said, in Switzerland, sometimes you cannot access a site for multiple days. So here I would tend to have a more resilient site itself. If you can cover it from other sites, then Carlo's approach might be helpful, because then if the one tower goes down and I can cover it from another side, why not? So it's very individual, in my opinion. So with that,
Yes, I agree. Me too. Maybe it's also depending about which is the scenario of the implementation. For example, if we are speaking about a scheme like low power, maybe you need a dense network. Or if you are looking mainly for the indoor coverage, you need to add more transmitter, more antenna, with limited power, of course, with low power application, but in that case can help add more site and more antenna.
Thank you. Very interesting. Thank you for this opinion. LP, what do you think is the next evolution for the resilience of multiplexers? I mean, you make a system, and Wolfgang, let's say, which have very similar performance and characteristics for resilience and redundancy. Do you think there will be a future evolution?
Yeah, I think AI will play a significant role here. What I have seen in some demonstration is in the most obviously part in the production base, producing jingles, advertising. AI can produce news for you, for example. So on the production side and metadata, I think AI will play a significant role. It's already happening, but also it will expand to other things in the chain. And AI is already in use heavily when it comes to the developing part. We use AI all the time to solve complex problems, implementing new features. So things go much faster now with AI. And AI is also quite good of understanding source codes, complicated specification. So I foresee that AI will be a tool for the users, for example, to interact with the APIs, and we can build tools for monitoring, controlling the platform, and other things. So, well, who knows? Maybe AI can develop a complete head system without us anymore. I don't know.
Wolfgang?
I think the next step, what we see worldwide, is really the regionalization. Yeah. So and we see now in Spain there is a request for 52 ensembles, which means the traditional technology means we have a lot of server PCs or a lot of units, and I think the density must be higher. That is one step we focus on in the next years, definitely. Because it costs a lot of money at the end if you want to establish 50 or maybe 100, or in Thailand, and there are also a lot of ensembles planned, or they started already, and they need, of course, a solution which you can pay for. So and the price must fit. Yeah, that's the end, and we cannot reach that if we have for each ensemble separate devices. That may be too expensive. But on the other side, you have to look, if you have, let us say, 20 multiplexers running on one machine, that means if the machine fails, we have switch all 20 multiplexers at the same time to a backup machine. It's also not really good, but at the end, it is a possibility. Yeah, you have to, as customer, you have to define what you want. Yeah, and how independent you want to manage your multiplexers as the NDR. That was a clear decision to have really 17 independent multiplexers instead of having a virtual machine with 4 or 5 multiplexers. Yeah, and at the end, it's really the question of the customer what they prefer. Yeah, and of course, it's always a matter of money. Yeah, and what we want is, of course, we the same as last Peter, is that we want to give everybody the best solution which fits in their requirements. Yeah, and therefore we try to cover all scenarios: the hardware scenario, the software scenario, the high density scenario, and something in the middle. Yeah, that is what I see in the evolution, so that you have really all possibilities. Yeah, and of course the next step, the ASA functionality. I'm sure that will come definitely. And yeah, as Lars Peter said, AI, we never know. Nobody knows really what happens in the future. Yeah, and maybe we do only AI agents at the transmitter side, and they do the complete program. Could also be a nightmare, in my opinion. Yeah.
Virtual transmitter would be a nice evolution.
Sorry, no.
Okay, so I got another couple of questions pouring in, and this one comes from Gilles Clerc. For transmitter side redundancy, he says, we're considering 4G, 5G as an emergency backup link. And this has been mentioned before also by Alex, I think. The cost of signal provisioning, like fiber or microwave, is often a major factor, so mobile networks could potentially be a cost-effective alternative. However, fair usage policies and latency stability can be a limiting factor, of course, when you see 4G, 5G. Have you seen reliable 4G, 5G redundancy solutions in a real broadcast environment? And do you think 5G with a QoS or slicing could eventually provide broadcast-grade reliability? Or will mobile networks remain just best effort backups? This is long question.
I get the question because we've been discussing this with a couple of our customers, and in my opinion, it will remain an emergency backup, not 100% replacement. What we see, especially in the United States, is that studio transmitter links for radio that do not have the 2 megabit or 2.5 megabit you need for DAB, but those people run it on Starlink. So that is obviously a cost-effective alternative, giving you a stable signal, a reasonable bandwidth, and then besides the Starlink, they are using 4G, 5G, especially in a bundled connection, as a backup. So
maybe I have an information I can give here. We had the case in UK with, for one site, a customer was willing to start the site very quickly, and it was not possible to have on time the planned connectivity for the site, the fiber. So he said, okay, let's use 5G to start already, and we will then move to the fiber. And the result was the following. It was working at certain moment of the day on the network in UK, meaning it was working well at night, it was working well in the middle of the morning and well in the middle of the afternoon. But outside this period, it was always glitches and hiccup. And we don't talk about network impairment that could be coped by all the mechanisms you have seen already today described, and even with long latency. It was really nearly no connection at some moment for that. And here I'm not talking about fair usage policy, because the second step was say, okay, let's see if we can have a contract with more priority and better access than the normal one. Then not all operator provides that. You have to go on some specific one who have this kind of offer. And this kind of offer, trust me, they are not cheaper than a real fiber often. So it's just an information I give from a real experience we had in UK, because the customer was really hurrying to switch on a site before it was ready.
Thank you. So last two topics. The first one comes from Philip of der Mauer from Sumatronic. And this also, I think, goes very much to Arne, Tork, and Stan. He says, if we assume that packet loss and burst behavior can naturally occur in an IP environment, are FEC, dual streaming, SRT, and RIST just the beginning of improving the robustness? Will there be further developments in this area? Are legacy ETI networks still more reliable today?
You want to start?
Yeah, it's difficult to see the future, but I think so what we've presented earlier is what is already being implemented for EDI and the DCP protocol, and I believe that this will not be further developed. So this is I think it's a good solution for managed networks and what can happen in managed networks. And if the networks are going to be less managed or a little bit more unreliable, we are looking on how to use technologies like SRT or RIST, as Tork said in our presentation. So because they are being further developed and are also being used for many similar scenarios, like for video or for audio distribution. So basically, we are using protocols which are established for transmitting data over the internet, for example.
Yeah, I fully agree with that. And I think, yes, you can add some tools in the application layer, on the higher layer to improve resiliency. But at the moment, there is a limit, there is a cliff let's say. I mean, you can invent whatever, very smart, etc. You will have to pay it with more bandwidth then, if it is a forward error correction, and then more bandwidth can be a problem for the network itself, or it can be latency. But outside this, even multi-stream, today it's not very difficult to make an IP network working well. I mean, we have all the technology, and especially with the addition during this last period with good synchronization, PTP, all of this. I mean, it's becoming every day cheaper, more normal to use this kind of tools. And you can really buy now for very low cost a small SFP module who are a master clock finally that you put on a switch, and you have your PTP there, and you can. So, I mean, honestly, it's always good to have a pragmatic approach on the infrastructure, on a system, to see where the effort is worth to. Because yes, you can build a very big, complex system, but if the basement of that is not good at the moment, I don't think it's the good approach. So IP doesn't mean it is not unreliable. It's the way how you carry it, or you transport it, or you manage your network. And today there is so much technology, from microwave and to different tools, that where the price are really lower than 10 years, 20 years, 30 years ago. There is also possibility to have easier license also on the spectrum to use this kind of equipment. So I think it's really important to really look at all the solutions you have and make the good choice from the beginning. And then when you have made this choice, it's very important to, because the choice may not be the same in different areas of the world. So that's why I don't say do this, do that. You have really to make the study. And then you have also to keep an eye on what's happening. So there is another point, which is you still have to do some very technologic to follow what's happening in the world, in the technology, because what is true today may not be anymore exactly true in 10 years or 5 years. So you have really to follow the things, and be really careful about just trend. Because a trend, I mean a mood, not trend, a mood to be more precise. Because sometimes you have also people or company who push a concept because they want to appear like it is the next thing, the big things, but you have really to look in details how the technology works, not just, let's say, the bells and whistles. So that's what I can say here in general.
Okay, thank you very much, Stan. We are nearly at the end, and I would like to close this Q&A with a question, or I have two questions, which we were discussing actually also last year, and which Stan already touched, which are short and long-term GPS disruptions in the network. Now we're seeing also a lot of GPS jamming on the borders, for example, of the Nordic countries or of the Mediterranean countries. Do you have, I mean, you mentioned some stuff, Stan, before, of like time reference transmitter. What can we do to make, let's say, synchronization more resilient? What's your opinion? This goes to who wants to answer, yes. Also, I'm looking also at Alex. Do you think maybe I mean, we can have at European level again, like time reference, a DCS reference, something like that, useful or precise enough to synchronize DAB?
Yeah, the two approach I note here is, I mean, and I'm really speaking about asynchronous network, and if you do IP, yes, we can implement not only at the studio or in one single premises, you can use also PTP on a national-wide network. So that's a way to do it. And again, here the costs are going lower every day. So that's something that we have to monitor carefully. If today you told me, okay, you start Digris and you rebuild the network you have built 12 years ago, I will make already different choices in terms of hardware or equipment or architecture for the different tools we use for IP, because of all these clock mechanisms that are now easily available today. But the point of the idea of a terrestrial transmitter, it was, if you keep, let's say, one-to-many distribution signal via over the air, for sure, when you have a national transmitter or even wider, it's more difficult to jam than a satellite constellation coming only from the sky. And keep in mind that here the idea is with the technology inside every transmitter today, modern DAB transmitter, and with the holdover mode plus an external clock you can send over the air, you don't need to have this clock all the time over the 24 hour. So if you go back to the old time of, AM, etc., and NVIS like propagation, for example, if you talk about local propagation, you don't need to necessarily say, I want to have the signal 24/7 always on my receiver on each side. You need to have at least your timing information long enough, a few times per day or one time every 24 hours, to keep your transmitter in line, in sync in the SFN. So here I don't have a miracle scenario. I said there is a lot of technology paths to or solution to tackle this issue. I don't say there is one. Keep also in mind that radio and DAB is not the only service who need this kind of synchronization. So if you work at the national level or European level, you can also say, hey, we are a lot of people who need this service. So you can have also a board or an organization who is providing managing the service, providing the service for everybody in a secure way, because it's not only one transmitter. I think it has to be a bit local. When I say local, it's, let's say, national, because it's very hard to jam national-wide signal on some specific band all the time over the year and over the day, because of the nature of propagation and radio waves. So it means that the system can use more than one transmitter and different band to have something very resilient. And it's not really a problem of cost for receiver, because even multi-frequency receiver, multi-band receiver today with today's technology they are not expensive to build and to make. So we know how to do strong modulation. We know to use modulation that works, as we said, below the noise. It's not really true because we compare to wideband signal. But let's say we have a lot of technical solution today that can be, I think, afford to do that without satellite.
Alex, can you see a scenario where, as a manufacturer, you implement, let's say, extremely powerful local oscillators to have a very long holdover, let's say 3 days, 4 days, for example, for, let's say, extended jamming periods or bad weather or some issues to GPS, and also to implement, let's say, this kind of synchronization using broadcast signals?
Well, so the first thing is the local oscillator inside the transmitters are temperature controlled oscillators, typically aux-codes. There are aux-codes plain and simple, and then there are improved versions of it. And we can provide improved versions upon request. Costs a little bit more, but it's possible. The other thing is, and you mentioned it already, PTP can be used to drive our clock and synchronization module. It has typically 1 or 2 satellite inputs plus a PTP input. And it outputs a 10 megahertz 1 PPS signal to the site. Now, if there are other ways for working in PTP, I'm not familiar, but all the transmitter manufacturers typically use a 10 megahertz 1 PPS signal for synchronization in an SFN, as long as you can create this from another signal that works well. We're always talking about GPS jamming. Most modern receivers, including our own, support Galileo, GLONASS, Baidu, GPS, and I heard once we support 7 kind of positioning systems. So if you have a connection to one of the others, you may be lucky that this is not jammed. But as all these signals are very low in the spectrum, the power is very low, it's a tricky discussion to have. So my personal opinion, having a more accurate aux code for longer holdover times, and maybe thinking about an external device that gives you a 10 megahertz PPS signal derived from an NTP input. But
Okay, thank you.
Can I say something? Just to,
Yeah,
just a
sure.
sentence. In our tunnel systems, what we are doing is that we have developed an RF module where we extract 10 megahertz, or actually PPS, from the public service DAB signal. So we are independent from GPS when it comes to the tunnel system. Of course, we rely that that public service signal is correct and locked, but technically it's quite easy to develop an RF front end that can extract something that is synchronized. So maybe that's something to build something new on. I don't know, but we still need that national reference broadcast. But that shouldn't be that tricky. I don't know. It doesn't have to be correct. That's what I mean.
Yeah.
As long as it's the same, it can be a fake PPS.
Exactly.
yeah, it's worth thinking about it, but it might be, you know, two things synchronizing of each other. So it works in the tunnel perfectly, I'm sure. But if everything else outside the tunnel is spoofed, then
Yeah, I was thinking
you run into problems.
on national basis, if we have a time reference that everyone follows,
Yeah,
then it will work.
likely.
So you should, DG should build a national pulse, one PPS system.
Okay, so I will bring this Q&A to an end now. Thank you very much, because I think it was really interesting, and it was really nice to have you here and discuss so openly the issues we are facing every day. I think I hope for all the attendees, both here in the room and online, this has been, so I pushed it. It was really pushed. Anyway, as I said, thanks to everybody for this really good discussion and Q&A session. Thanks to everybody following the seminar online, and thanks to everybody coming to Geneva.